Thank you so much, and apologies for not joining you by video, but I had some technical difficulties earlier, so hopefully this works much better. My name is Koen Deconinck. It's a pleasure to be here and to share with you some of our thinking at the OECD on how to measure carbon footprints and perhaps also other footprints of agri-food products. And if we turn to the next slide. If you are here, you probably know that the food we eat is linked to some of the world's most pressing environmental issues. This is true whether we are talking about land use, deforestation, biodiversity loss, water use, water pollution, and climate change, which will be my main topic here. But you will see that some of the lessons here also apply to those other environmental issues. And if we move to the next slide, you will probably also be familiar with this finding that when you look at greenhouse gas emissions from food all across the life cycle, most of it happens very early on in the life cycle. Most of it, 70%, happens through land use change, and primary agricultural production. And you can see that all the other bits of the life cycle, of course, add a bit to that, but the bulk of the problems are really happening very early on in the life cycle. If we go to the next slide, what is interesting is that in the last few years, there's been an explosion in companies disclosing environmental impact information. Now, the information I'm showing here on this particular slide is not specific to agri-food companies, but it does give you a picture of what's happening out there. This is data from CDP, which is a platform where companies can disclose their greenhouse gas emissions and other environmental impacts. And as you can see there, there's been a very strong exponential growth with more than 25,000 companies currently disclosing that information. And those include some of the world's largest companies. So I think it's roughly 2/3 of the global stock market capitalization is actually using this platform to explain what their greenhouse gas emissions are. If you go to the next slide. Increasingly, companies are not only talking about their own emissions, what we call scope 1 emissions. So scope 1 emissions would be the emissions of your own factory or of your own activities. Companies are also reporting scope 1, scope 2, and scope 3 emissions more and more. What does that mean? Scope 2 means the emissions from the energy you're purchasing, for example, the emissions of generating the electricity that you're buying. Scope 3 means the emissions of everything in your supply chain, upstream and downstream. So if you are a retailer, then your upstream emissions include, for example, the methane emissions of the cows that generated the milk that became the yogurt on your shelf. Or even further back, the emissions from the deforestation for the production of the soybeans that were fed to those cows, and so on. So it's a very far-reaching concept. And downstream as well, for example, for the supermarket, downstream emissions would include whether people took the car to come to the supermarket. So it's a very expansive concept, but we do see that more and more companies are reporting their scope 3 emissions, and not just reporting, because if we turn to the next slide, you'll see here that leading retailers are increasingly setting scope 3 targets. So companies are committing that they will reduce their emissions, again, not just their own emissions of their own activities, but those total scope 3 emissions. And here I took a sort of a who is who of the world's leading retailers across different OECD countries. And you can see that no matter where you look, you will find major retailers making those kinds of commitments that they will reduce, for example, their food and agriculture related emissions by 72% by 2050. That is actually a very common target that many retailers have set. And if we go to the next slide, you'll see that this is even true for Canada, where for some of the leading retailers in Canada as well, the targets are not necessarily the same as what you saw on the last slide, but lots of large retailers have also set targets to reduce their scope 3 emissions over time. And it's not just those companies. You could think if you're a Canadian farmer, well, maybe you're exporting, maybe you don't care that much about what Canadian retailers are doing, but you would care about what is on the next slide then. Because we also see that, if you go to the next slide, please, that even the world's largest commodity traders are setting those kinds of scope 3 targets. So you can see here ADM, Bunge, Cargill, LDC, COFCO, all of them have made some kind of commitment or some kind of target that they will reduce not just their own emissions, but the emissions in their supply chain, which of course means to a large extent agriculture and land use change. And if we go one slide further, you will see also increasingly that there's other initiatives popping up that go beyond greenhouse gas emissions. There's just a handful that I randomly selected here. The Science Based Targets Network is trying to do for all kinds of other environmental impacts to get companies to set targets to reducing those impacts as well. The Task Force on Nature-related Financial Disclosures is trying to come up with reporting standards that financial companies, that companies could use to disclose those kinds of impacts. In the European Union, the European Commission has been developing the product environmental footprint methodology, which, as you can see in the middle, has 16 different categories. So this includes climate change, but it also includes things like ecotoxicity, eutrophication, water use, and so on. And we even see this pop up in labels. So the picture at the bottom right is from my home country of Belgium, where a leading retailer has now started putting these kinds of green scores. It's a letter score that actually is synthesizing those 16 different impacts in one label. So if you go to the next slide. Another finding, if we look at the literature on environmental impacts of agri-food products, apart from the finding which we mentioned earlier, that most of it happens very early on in land use and agricultural production, another finding is that there's large differences between different types of agricultural agri-food products. And I'm sure you've heard different versions of this before. This is data from a major global assessment, so these are global numbers. Globally, it's quite clear that animal-based products have much higher carbon footprints than plant-based ones on average, and that within that, the ruminants, the beef, etc., those tend to have higher carbon footprints than non-ruminants. But what is less well known, even though we can find the data in the exact same study, is if you go to the next slide, you can also make the following picture. This picture, again, drawn from the same study, from the same data, shows you the little white dot, which is the global median carbon footprint, and the gray bar, which is the range between the 10% best and worst producers globally. And as you can see here, that range is enormous. So that means that an average number could be quite misleading. You'll also see that the pattern, the broad pattern still holds, right? But in any particular case, the average numbers could be quite misleading. And if you go to the next slide, if you think a little bit more about what that means, that variability, it actually suggests that there are multiple levers to reduce carbon footprints of food systems. The first one is, given the chart we've shown there, is people could shift towards lower emission product categories. And this is the well-known advice that people could move towards more plant-based diets. That is one example of that. Or the idea of a flexitarian diet, where you shift from beef to poultry, etc. That is one example of that kind of thinking. That you can do if you have the average data. But if you go beyond that, if you have the underlying real numbers, you can actually go much further. You can do much more interesting things. Because the second lever there is that within each product category, we could shift to lower emission producers. So like the lady in the picture who is choosing milk in the supermarket, if you're still consuming milk, you could at least pick milk from a lower emissions supplier, a lower emissions producer. That, of course, is only possible if you go beyond the averages. But then another interesting thing happens if you had that data, if you had good primary data and you knew the actual carbon footprint of different suppliers, then it means that everybody would have an incentive to start adopting practices and technologies that lower their emissions. So you get a dynamic effect over time. That is the third lever shown there. Or if we go to the next slide, if we translate this back into the chart I had shown you earlier, the first lever is the big green arrow on the left. It's basically moving down on the chart. The second lever is the green arrow you can see there in the middle. It is the idea of, within each gray bar, moving you from the right to the left. You pick a supplier, you pick a producer that has a lower carbon footprint. And if you go to the next slide, the third lever is really about taking this entire distribution and squeezing all the bars to the left over time, getting that improvement over time. And people have often focused on one or two of these levers, but it's rare to see all three of them addressed together. But that is what you can do if you have much more accurate information much more widespread and reliable information on the carbon footprint of food products. If you go to the next slide, the big question is, can you do that, of course? Because it's one thing to come up with the hypothetical that if we had great data, all kinds of things would be possible. But what would it actually take to move beyond averages in those kinds of calculations and to do it in a reliable way? Well, it is a pretty daunting task because we would need quite detailed information on what's happening on a farm. We would need quite detailed information about the feed production, the fertilizer production, the fuel and electricity. And then you would also need that data moving through the supply chain with primary data from all the other supply chain stages added in all the way down to the final consumer. So that is, of course, a big task. If you go to the next slide. What is interesting is that in the private sector, people are asked to do these kinds of scope 3 calculations. And they have, of course, been struggling with very similar issues. And this is a cross-sectoral problem. And so people in industry got together and came up with the PACT principle, which is the Partnership for Carbon Transparency. And their idea is, if you take this enormous problem and you cut it down into smaller, more manageable pieces, what you could do is, if you were able to receive good data from your own suppliers, then all you would need to do is basically add information on your own emissions, which is the part that you understand best. And then you hand over that total number to your customer. And this way, step by step through the supply chain, you could actually build up a carbon footprint calculation that is increasingly based on more and more primary data over time. So if you go to the next slide. We've taken this ambitious idea and this PACT principle, and we've last year, 2025, published an OECD report where we applied that thinking to agri-food products. And essentially, our report is asking, what would it take if you were to apply that logic to the agri-food supply chain? Because we know that it is a much harder sector to do these things. I have colleagues who work on the steel industry, and I often remind them that there's only about 1,000 steel factories around the world. That means that if you wanted to, with a small team, you could visit them all in person. As you know, there's more than 600 million farms out there globally. So that is clearly a completely different order of magnitude that we're dealing with in our sector. Yet, we do think there's something to be said for this idea of at least exploring it and asking the question, what if? What would it take? And so with that spirit in mind, we came up with 8 building blocks. So we basically started thinking backwards. What would it take if we wanted reliable and widespread carbon footprints of agri-food products? What would be the necessary ingredients for that? And then we came up with this list of 8 building blocks, and I'll quickly walk you through them over the next few slides. But 2 key messages here are that, perhaps surprisingly, those building blocks are actually falling into place. There was none of those building blocks where we found an absolute gap, where we really found no solutions whatsoever. Most of the time, somebody somewhere had figured it out already. Although in many cases, what we found is that a lot of these solutions at the moment are not yet connected to the other ones. So there's a lot to be gained from learning and building on each other's work. Another lesson is that none of these building blocks are really carbon specific. And so therefore, yes, you could ask, could we do something similar? Could we apply the same kind of thinking to other environmental impacts as well? If you go to the next slide, please. The first building block is that you need good reporting standards and guidelines, which basically tell you what you need to report, how you need to report it. So for example, if you are a farmer and you want to calculate your carbon footprint, should you include the emissions that were necessary to produce your tractor? Is that something that you should count or not? Those kinds of questions are answered by accounting standards, reporting standards for greenhouse gas emissions. And if you're new to this, it can be really, really intimidating because it's just an alphabet soup. And the way we think about that is as this pyramid where you can actually rank them all from the more firm level ones on the left to the more product level ones on the right, and then the more general foundational ones at the bottom and the more specific ones on the top. You can see that 2 main players are the Greenhouse Gas Protocol and ISO. And so far they both had a standard for the firm level and for the product level, which was a bit confusing, but they are now actually working to merge those standards. So that will actually simplify things. And if we go higher, you'll see that Greenhouse Gas Protocol also has a land sector and removals standard. So that was in development for many years. It came out as an official standard just a few weeks ago. So that is a big change now in the landscape. And now many other actors are now aligning themselves on that. And if you go higher and higher, you can see that there's more specific guidelines. For example, the International Dairy Federation has a guideline on how to do carbon footprints in this sector. So you get more and more specific, answering more and more specific questions. But that brings you to the top of the pyramid, this big question mark, because none of those standards will really tell you, if you have a cow in a field somewhere, how much methane did it burn? The standards are not really designed to do that. But you can find more on that if you go to the next slide. Because the second building block is that we need science-based methods to quantify emissions. Now, ideally, we would be literally measuring emissions. In reality, that's very hard. You can do that for scientific research. You can, for example, bring a cow into a respiration chamber and actually measure the amount of methane. That is not something really practical day to day. So what people do is that they take that science and translate that into simplified estimations, equations, and so on. And the way that you do that, which parameters you use, which equations, those things can be found in scientific guidelines. And one of the most important ones is the IPCC guideline, which was actually designed for governments. It's actually to help governments make their greenhouse gas inventories. But increasingly, we see countries downscaling that to the farm level, because even though the science is the same, a farm is obviously not the same thing as a country. So you do need to make some modifications and adjustments and extra assumptions. And how you do that is something that countries are increasingly providing guidance on as well. If you go to the next slide. The third building block is farm level tools, because it's great to have scientific methods, but if they're just in a very complicated PDF document, that is not something that farmers can actually use. So what you need is a way to bring that alive and to make sure that farmers in a simple, in a convenient way can input key parameters for their farm and get a reliable estimate for their greenhouse gas emissions. Now, if you are here, I'm assuming you're familiar with the HOLOS model, so you probably know very well what that is and how that works. And if you go to the next slide, we've been working in the OECD together with Australian National University over the past year or so to actually gather information on all the tools like HOLOS that are out there in the world. And we found information on 200 tools, of which more than 180 are currently active. And as you can see on this chart, the number of active tools has really exploded over time. So since 2020, that number has gone up by 88%. There's also an interesting landscape of tools. Some are private, some are public, some are more research-oriented, some are public and private partnerships. And you can see especially strong growth among private tools. So there's really a strong explosion of tools that have been developed by the private sector there. And we're currently still crunching the other information that we gathered on exactly how those tools work and how they differ. If you go to the next slide. So the good news there is that the tools exist. The bad news is there's room for improvement. So a lot of those tools were originally not designed for product carbon footprints. So you can often have a number, but it's not something that other supply chain actors can really use. You can fix that, but then it means that you have to do a bit of extra work to make sure that you align with the relevant standards. And that is the second point there. I showed you that pyramids with the different reporting standards. Again, the tools were often developed with very different purposes in mind, and not necessarily with this idea of reporting according to a corporate reporting standard. So often all the raw material is there, all the raw ingredients are there, but they haven't yet been put together in a way that would make sense to somebody who has been asked to do Scope 3 reporting for a retailer. And perhaps a more troubling point is that a review by the UK government in 2023 found that tools can sometimes give very different results for the same farm. So that is something, if you have a landscape with many different tools, and if the tools can all make slightly different assumptions, slightly different methodological choices, you could end up with quite a confusing result for farmers and other stakeholders. And that is actually a large part of our current work at the OECD is on how to deal with that. If you go to the next slide. You will not always have primary data everywhere, definitely not in the beginning. And so the good news is that there is also a growing body of secondary data which you can use as inputs for calculations or as default values if you don't have the primary data. And you can see there the first result. People have actually shown that you can use that to make a first estimate of the environmental impacts of 57,000 food products, which is basically all the food products you can find in your typical UK retailer, which was what they were looking at. If you go to the next slide, Some secondary data sources are specific. For example, the Global Feed LCA Institute gives data specifically on animal feed. And if you go to the next slide. The next slide is about how to share data along the supply chain. So that's the fifth building block there. Again, this is something that lots of people have been working on recently. And again, in the private sector, leading initiative there is PACT, which we encountered earlier. They have set up a technical infrastructure to allow different kinds of accounting tools to actually communicate carbon footprint data with each other, to export and import that in an easy format. And this is something that is getting a lot of traction in the private sector. And this is not the only initiative. There's many other initiatives like that around. Next slide, please. I'll go quite fast on this one. There's also the question of quality assurance. There, as always, we have an option of first party, which would just be self-declared, second party, which would be, for example, the buyer inspecting it, or third party, which would be having a neutral actor do that. The difficulty there is that at the moment, there's not yet a good way of evaluating the methods, and the current approaches are also expensive and hard to scale. If you go to the next slide. This is this seventh building block for me is a very important one. It is about how to scale it up. And as I mentioned earlier, and as you know, it is a very fragmented sector. There are lots and lots of small operators. So this is very different from other sectors, other supply chains. So there's different strategies you can take to make this more manageable. One is to, rather than asking everybody for massive amounts of primary data, that we start first from default values, from secondary data, from other estimates, and we gradually replace it with more and more primary data wherever possible. There's other ways of improving the availability of that data. For example, private sector engagement with suppliers. We increasingly see this in the dairy sector globally. Public-private awareness campaigns have been quite successful, for example, in New Zealand. And I'll talk a bit in the next slide about an interesting initiative in Ireland called Origin Green. So in Ireland, the Origin Green initiative was actually a pre-existing sustainability scheme. And at some point they realized we have this much data anyway, we might as well ask a few more questions and calculate carbon footprints. And they've been doing that since 2013. And they have calculated thousands of farm-level carbon footprints. And they cover 90% of the Irish beef farms and 95% of the Irish dairy farms. So this is nearly universal farm-level calculations, which shows that actually under the right circumstances, it is possible to scale up these things. Next slide. Initially, we only had 7 building blocks, and at the end, we realized we needed an 8th one, which was how do you update and align all these elements? Because there are a lot of moving parts here. And the tricky thing here is that you simultaneously want flexibility and stability. Flexibility because the science and the technology will keep changing, but also stability because it is confusing if people keep updating things left and right, and then your numbers keep jumping around, and you're never quite sure whether two numbers from two different companies are actually calculated using the same methods. So that is something that people need to be thinking about. One way of doing that is to have regular updating cycles that you announce in advance, where you say every 2 years we will be updating this method, or every 1 year we will be updating this particular database. Next slide. So I like this picture, and this is just a small sampling of the many initiatives we've come across in our work on measuring carbon footprints of agri-food products. And you can see it's a pretty confusing landscape. And on the one hand, it's great to see this much energy and this much initiative going into what is a really important and difficult problem. On the other hand, you can't help but wondering, is all of this now leading to collaboration and convergence, or are we just getting more and more fragmentation and confusion? And this is actually the reason that we at OECD have been working on this question. If you go to the next slide. So you can see here that at the OECD, we've been bringing together policymakers and experts from around the world to discuss these issues and to avoid fragmentation. Next. This involves discussions with our member states and experts. And you can see here that just next week, for example, we will be discussing the HOLOS model and in particular the open source aspects of it. So this will be discussed among our 38 member states who have all been studying a case study that we've been developing joint with the HOLOS team in agriculture and agri-food Canada. Next. Now, could these 8 building blocks help with other environmental impacts? I think so. So if you go to the next slide. most of the farm level tools already cover at least one other environmental impact. I mentioned the database we're building. So this is one of the questions we ask is, apart from greenhouse gas emissions, what else are you covering? And you can see that the most common other one is water use. And you can see the entire list there. So a lot of tools actually do think already in terms of multiple environmental impacts. And if you go to the next slide. We've been working on the topic at the OECD, so you can see a few of our publications here. We've been publishing academic papers, we've been publishing things with the business world, and also last year our report, our OECD report that came out on that. Next. So where are we going next? We're currently focusing, as I mentioned, on methods and tools for farm level greenhouse gas calculations. We think that that is the most impactful thing for us to focus on now. How are we doing that? Well, an important part is that we are facilitating dialogue between policymakers and experts to better understand each country's methods and which kinds of tools are available in those countries. We have worked with 38 countries from all over the world, so there's lots to learn from each other. We also engage with experts and stakeholders, including the HOLOS team. We've actually learned a lot over the last few years from extensive discussions with them. And one of the things we do is that we organize webinars where we share those insights and experiences. And so if that is of interest to you, you'll see my email address there. Please feel free to send me an email and I'll be very happy to add you to the mailing list. And with that, over to you.